Hello, ladies and gentlemen. Please let me know if you have any troubles to hear or to view slides, but if everything is okay, we can start. So I'm doing PhD in MIPT about autonomous AI systems in corporate governance. And today we talk about ethics and law in AI. What is going now? Now is a big paradigm shift in management, and AI systems from supporting mode are going to uh, decision uh, making roles. But we cannot have just Skynet. We need to have a system which complies with the law, with ethics, and generally care about us as humans. What are the main systems which are now already are appointed as the top managers for big international companies? First of all, it's digital command centers like Panorama of oil company ADNOC. Second one, there are several personalized systems. It's virtual agents and humanoid robots. Some like robots CEO Mika and robot Sophia, and virtual agents like Alicia T, Agent Insight, Tang Yu. Tang Yu is CEO of Chinese company. And we can expect that we will have a hybrid systems when we connect digital command centers and some personalized systems like interface. And what is going on? When we have a digital command center, we can process a lot of data. Of course, this is for big data. When we have a humanoid robot, for example, it is about social interactions with humans and corporate leadership. And then when we combine together a digital command center and humanoid robot, for example, we will have altogether big data and social communication and corporate leadership. And how it looks like. So here we can see digital command center panorama. Here we can see virtual agents. It's Iden inside, Tang Yu, and Spock, for example. And here we can see robots, CEO Mika and robot Sophia. And now we can think about emergence of hybrid systems. So if you have like interface now papers, for example, then we can have as interface, for example, a humanoid robot or virtual agent. And to implement such systems and not create a new Skynet, we need some elaborated approach. And we propose the reference model according to which we can develop and implement such systems. So this model includes a computational law, dedicated operational context, controllable generation of synthetic data, strategy calculation, and presentation and communication. And today we will talk about a small prototype of that model, which is prepared, which is coded on Python. And on this prototype, we can see how this reference model can be implemented in reality. It is end-to-end process for autonomous AI system to make a decision from raw data to final, very responsible, ethical management decision. So we start from raw data, then we check requirements of computational law, then we check requirements of dedicated operational context. After that, we use controllable generation of synthetic data. Then we use strategy calculation for decision making, and then we go to presentation and communication. For analysis of this small prototype, we use three scenarios. One is for validation of data for purposes of gender diversity in the board of directors. One, to detect manipulation of subsidiary value on Enron corpus. And one scenario to assess quality of synthetic data for the purposes of board of directors. First step is computational law. What is going now? If you look, for example, for European law, we will see that they use a word any. Any discrimination based on gender is prohibited. But what does mean any for autonomous AI system? Actually, it means nothing. Just for example, you can see for algorithmic fairness, let's use starting difference based on adult data set, and we can see that we will have some figure, not any. And any our AI system is not able to understand. So we will need a special algorithmic law for such AI systems. The second point is about dedicated operational context. I think you all know that we have Robot Sophia, which was recognized as a citizen of Saudi Arabia. And in reality, this robot got much more rights than women in Saudi Arabia. So this is not a good case. And in our model, we say that AI systems should be provided with a dedicated operational context. And to create this dedicated operational context, we can use, for example, some kind of dictionary and say that, okay, algorithmic fairness is, for example, start mid difference, and range for fairness is between, let's say, -1 or 1 or less. So for such systems, we have to provide an interval because otherwise any means nothing. The next point in our model is about synthetic data. Actually, synthetic data have much more importance than we could think from the first point of view. All our current data are historical, and if we have any bad patterns in our history, then we use historical data and just move these wrong patterns to the future. And here we should think about synthetic data, and we can use synthetic data to change wrong historical patterns from the previous years and move forward to the better future. So what we are talking about, when we think about gender equality, we think, okay, 50% for men, 50% for women. But if you go to Gemma, LLM from Google, and ask this model to generate occupations for girls, we can see not top managers, teacher, doctor, lawyer, nurse, writer, engineer, chief, artist, musician, architect. So in this case, we cannot use any historical data. If you want to go for gender equality, we have to use synthetic data. Strategy. The next step in our model is about strategy. What we have now? Usually, we have a list of algorithms, for example, in self-driving cars, etc., which are trying to find a way how to move safely. But actually, every manager will tell you that you cannot just check one algorithm by other. You need to have a strategy. And to calculate a strategy, we use again theory. So this is a tiny example when we can create a pair of matrix and calculate a strategy: strictly comply, reasonably comply, somehow comply, and what could be the cost: high cost, medium cost, and low cost. And actually, the main point here is that you don't need to check algorithm by algorithm. You have to have a strategy how your AI system will get to the target point. And now we are going to the presentation and communication. So generally, now we have two main types of interfaces. One is for digital command centers. It is, of course, huge dashboards. And second type of interfaces is for virtual agents and humanoid robots. And of course, digital command centers now have much more better opportunity to present the decision flow because they can show all data process step by step. And here we are talking about the combining digital command centers and personalized systems like virtual agents or humanoid robots. And then we will have two benefits in one. First of all, we can present big data processing, and second one, we can ensure social communication and leadership. So, for example, for such a system, we will have a global flag. If it is display mode, then present data. If it is agent mode, then tell something nice, for example. And what is going now? We are moving very quickly to the time of autonomous AI systems, and we need to strive to make such systems not a Skynet, but human-centric. So there are a lot of references, of course. That's mainly on. Thank you very much.
Thank you, Anna. Let me ask you, Anna, could you tell us about the most difficult challenges in this area nowadays?
Well, from my point of view, the main challenge is that our technical skills are much more advanced than our law and ethical technologies. So we can produce such systems, but we cannot ensure that these systems will be ethical and lawful. So this is the main point.
Okay, thank you. And is it possible to incorporate the solutions nowadays from the law perspective?
Yes, again, this is the target point to develop and introduce algorithmic law a special law for AI systems, and based on this law, we can have our autonomous AI systems. It's some kind of Asimov law, free law of robotics, but of course on the modern level of science.